So let's start with hysteresis, because it's a term not very known to all of you, because so the idea comes from physics, magnetics, but you find it in every science, let's say, so in engineering, biology, and in economics, so especially in the international trade and the labor market theory, but also I recently learned in migration theory, so it's everywhere. And characteristics for hysteresis are non-linearity and path dependency. You will see this in the first example. Here we have the very basic model of hysteresis. You've got an input variable which goes up and down, and you have two states of the output variable. And in my framework, the input is the exchange rate, and the output is the exporting of the firm. So if the firm exports, it's 1, and if the firm does not export, it's 0. So the idea is there's an exit entry threshold. So when the exchange rate, for example, the euro, depreciates, there will be one number when the firm starts to export because the products are cheap on the destination market. If the euro decreases furthermore, the firm will stay on this export market. But what happens when the euro starts to appreciate? So the idea of this hysteresis framework is that the firm will not exit the market at this point, but it will stay as long as variable costs are covered. So there is a second threshold, the exit threshold, where the firm will leave the market. Okay, so due to time reasons, I will skip my explanation and just summarize this baseline model. So each exporter is characterized by entry and exit thresholds. These are not the same. If they would be the same, we would have a perfect relay. For example, when you switch the light on and off, you have a perfect relay. But here we have not, because there is this band of inaction, here, this one here, where you can be in both states. For example, if you have here this value of the exchange rate, you cannot say if you are exporting or not exporting. You have to know where you have been in the period before. And why do we think this is a case, that such a behavior of exporters happens, is because of sunk costs. And now what we have to do, if one exporter can be characterized by such a non-ideal relay, we have to aggregate heterogeneous exporters. And when we do this, for example, here we have 3 exporters, and now the exchange rate goes in this direction, so the export rises, and when the exchange rate changes its direction, here nothing happens for some time, and then more and more exporters will exit the market. So you get what is called hysteresis loop. And now there are different methods which try to capture this hysteresis loop. For example, one method I use in this paper is the play algorithm. And here's the idea to linearize this hysteresis loop. So you get this kinked hysteresis loop. So why did I choose the wine market? Because we have seen before that the home consumption decreases, so exports become more and more important. So I will skip this because we already had the numbers in the discussion round. So in addition, it takes effort to export. You need relationships, and I found that there are many, many regulations on the US market. So, and if you would like, for example, to change from the US market to the Chinese market, for example, I think we will learn about this in other sessions, but I guess there's difference of tastes of the consumer, so maybe you would have to change the grapes. So there are sunk costs in these export markets. So this is a method with this linearized hysteresis loop. And the idea here is that you have one element which you would like to control. This is element number 2, and you have one element which you can control. And now you go. I will do it in this direction this time. For example, so I would like to control this, but I can only move this element. So if I go up, both elements go up, and as soon as I go down, nothing happens for some period of time, and then I go down with all the with both elements. And as soon as I change the direction, nothing happens, and then I go up. And if I just have little changes here in this interval, nothing happens. And this, exactly this we use. This is a loop again to do with the exchange rate. So the exchange rate varies, and what we do with the red line, this is this hysteresis variable which we use in our approach. This is where we filter out the small variations of the exchange rate. So we have here just, for example, a flat line. So this is just the phenomenon. And then we put this hysteresis variable in a simple OLS framework. Why do we use OLS? Because all this hysteresis variable calculating is rather complicated. So we use a simple model here for this estimating procedure. So wine are values, unit values, and quantities, which we took from Eurostat. And as you see here, we have the real exchange rate, US GDP, lagged one period, a trend, and seasonal dummies, so very simple model. And here we add this hysteresis variable, and then we are interested in the coefficient beta. And the other method I will just mention briefly. I use the implementation by Piscitelli et al. And what I get is a price of variable, and it's very similar to the one I just showed you before, but with another method, another aggregation method. So we start with this, go through this aggregation procedure, which I will skip due to time. And what I get here, so this is the exchange rate. This is the variable I shown you before with this linearized loop. And this is another approach to aggregate the exporters, which I call price of variable. So they are very similar. And then there are different ways in the literature to implement this price of variable in the estimation procedure. So I just test both of them. Here I add this price of variable, just like the other spread variable before, as a hysteresis variable, and here I replace the exchange rate by this price of variable. And as before, I use values, quantities, and unit values here for these wine variables. So let me briefly come to the results. I have here values, quantities, and unit values, and I test the 3 biggest exporters. And as in the title, I test or I analyze exports to the United States. So these are the 3 methods, and you can see H means I found hysteresis. Plus means I found hysteresis but with a wrong sign. So this is not that's a crazy result. Yeah, the euro appreciates and I would export more to France, from France to the US. And this means I did not found anything. So I've got a summary of the table before. So I can conclude that I found hysteresis in Italian values, and that's another result from a paper I've wrote before. The hysteresis in values can come from hysteresis in quantities or prices. So this was a theoretical paper, and I think it's very interesting because here we can say, okay, I found hysteresis just with the third method, so with the first method I show you, though it may come from hysteresis in quantities or from hysteresis in the prices. In Spain I find hysteresis in values, but neither in quantities nor prices, so that's a very interesting result. And in France I found hysteresis in prices. Here I've found the wrong sign of the beta coefficient, and here I find hysteresis in values only with one of the methods. So yeah, these are my results, and I've got interpretation, but it's more or less what I told you before. And due to time reasons, I would say I conclude at this point, and we come to the questions. Thank you very much.